Okay, so on your lab, the data was posted. You have, can you all see my screen first of all?
Yeah.
Okay, so the data you're given, you have time and absorbance data. And you have this for room temperature, and you have data for ice bath or like cold temperature. And so the whole purpose of this lab, you have crystal violet, which is purple. And so the more crystal violet there is in that sample, the more purple it is. When you add it to, I think it was like sodium hydroxide or something, as that reaction proceeds and the crystal violet's getting used up, its concentration goes down and it becomes less and less purple. And so you're measuring over time, how is its concentration changing? By using Beer-Lambert's law, which was A equals EBC. It's the absorbance is related to the concentration. And so the more crystal violet that's in there, the more purple it is, the higher its absorbance. As it gets used, the concentration goes down, it becomes less purple, and so the absorbance decreases. And so you have data at room temperature, and then you have the same data for the same reaction, but at a cold temperature. And so when we talk about figuring out rate laws, there's 3 different methods to determine the rate law. Method of initial rates, integrated rate laws, and then mechanisms. For this, we have time and essentially concentration data, because absorbance and concentration are directly related. So you have time and concentration data, which means that you're using the method of integrated rate laws to figure out the order. And so remember, with integrated rate laws, we're having to graph it. And so there's 3 different graphs. Whichever graph gives you a straight line, that tells you that's the order for the crystal violet. And so we have concentration and time data. So I'm going to highlight my data and I want to graph it. So I'm just going to go to insert, chart, and it automatically does a scatter plot. If yours doesn't come up as a scatter plot, then you can change it over on the side in the chart editor to what you want it to look like. It comes up as a scatter plot. So this is my concentration versus time, or absorbance versus time. If this is a straight line, then it's 0 order. But this one's not a straight line. It's got a curve to it. So then I move on. It's not 0 order. So now I try, it's not moving. Try first order. For first order, remember, we're graphing the Ln of the concentration versus time. And so to do that, I have to, in my data, I need the Ln of the crystal violet. And so I'm not going to do that by hand. In Google Sheets, I can say equals Ln, and it's going to auto-populate with that Ln function. I want the Ln of that absorbance value. And I'm going to hit enter. I want it to do that for every one of my absorbance values. So right here in the corner where it's got the little square, I can double click and it'll automatically populate that all the way down. Or you can just click and drag and it'll populate it. So I'm going to do that. So it's got time and concentration. And now that's what I want to graph to see if it's a first order reaction. So I'm going to highlight my time again. And to select another column of data, I need to hold down my control key. Oh man, what is that? Hold down my control key and select that next set of data. And then same, oh man. Okay, this worked better a while ago. So data. Oh, I held down shift. Control. Okay, now that I've got my data, insert graph again, or chart. And it graphed time versus the Ln. That one does give me a straight line. And so I know that this is first order with respect to the crystal violet. With this lab, if you had actually done it, you would have collected data for room temperature and then either a hot or a cold sample. And the reason is that we want different temperatures with different rate constants, because remember that temperature changes rate constant. It's the only factor that changes what your K value is. And with the lab, we are trying to find the activation energy for this reaction. And so we want to find activation energy. So in order to do that, we're going to graph the inverse Kelvin temperature versus the ln of K. And then when we get a straight line, R times its slope, or negative R times its slope, will give us activation energy. And so that's what we're trying to find in this lab, is the activation energy for this reaction. When you go to calculate activation energy, once you graph inverse temperature versus the ln of K, you get the slope. R is going to be the 8.314. We have two different R constants, one for gas laws with liter, atmosphere, mole, and Kelvin, and then the other one is with energy. So we're using the 8.314 joules per mole Kelvin times the negative slope, and that will give us the activation energy in joules. So that's what we're doing with that data. So you'll have different temperatures, different rate constants. You're plugging yours in. So the yellow is the stuff that you're changing. So you'll plug in from the other two tabs when you graph and get the equation of your line. Plug in those values for temperature and rate constant. And then you need to convert the temperatures to Kelvin, and then do the inverse temperatures, do the ln of the rate constant, and then you're graphing inverse temperature versus the ln of K, getting the slope and using that to calculate the activation energy. On your graph, the one that gives you the straight line, so this was my ln versus time, so it's first order. I know that the negative slope represents my K value. You could either calculate it by hand, or it's just easier to use the chart editor and tell it you want the equation of the line. So to do that, customize, go to series, and then I want it to show the trend line. I want the equation, and then you can tell it to show r squared if you want just to check like how close it is to actually being a straight line. Ours is 0.999, which is super straight, or matches the data, correlates really well. So this is the equation of my line. And so my slope is negative 4.48 times 10 to the negative third. So I know my K value for this data at this temperature is 4.48 times 10 to the negative third. And so that's what I would take and plug in. Here's my rate constant and the temperature that's given at the top of the data. And so you're doing that for room temp and cold, plugging them in, and then you're analyzing the whole class data to find activation energy.